2025 A-Level Combined Mathematics Paper 2 Part B Question number 11 Part A. This question has to do with velocity time graphs. The question says, a particle P moving with a constant deceleration of f meter per second squared along a straight line passes a point O with a velocity of 60 meters per second at time t equals 0, where f is a positive number. So f is a positive number indicates, of course, that the deceleration is in fact positive, and time t equals 0 indicates that we start counting time at this particular point, the point at which the particle P passes the point O. It then says, just after the particle P comes to rest, it moves towards O with a constant acceleration of f meter per second squared. So after going forward past O and stopping, it turns around and starts coming towards O again with the constant acceleration of f meter per second squared. It then says, at time t equals 30 over f seconds, another particle Q, which was at rest at the point O, starts to move towards P along the same straight line with a constant acceleration of f meter per second squared, and after reaching a velocity of 30 meters per second, continues to move with this constant velocity. So basically, this particle is going to accelerate until it reaches 30 meters per second, at which point it stops accelerating and moves with constant velocity. It then says after that, the particle Q meets the particle P 10 seconds after the particle Q reaches the constant velocity. So basically, as it's going accelerating, stopping and reaching a constant velocity, 10 seconds after this point, at this point right here, the particle Q has reached the same exact point as the particle P. So they meet. Then says, sketch the velocity time graphs for the motions of P and Q from t equals 0 seconds until they meet in the same diagram. So basically we'll be sketching a velocity time graph which will contain both the graph of P's motion and the graph of Q's motion. It then says, show that given all of this, f is equal to 3, as in this value f, which is the deceleration of this particle, the acceleration of it, and also the acceleration of the other particle, is equal to 3, and that the distance from O to the point at which the particles meet is 450 meters. Now to answer this question, what we are asked to do first is to sketch the velocity time graphs. But before that, let's actually just draw a simple straight line which I'm going to draw as an arrow and try to figure out the motions of the particles P and Q. So considering this arrow, let's suppose that this point which I'm going to draw right over here is the point O on this straight line that the particles P and Q are traveling on. So first, let's consider the motion of particle P. Let's suppose that we consider time t equals 0 and the moment that particle P passes the point O. So at that moment, particle P is going to have a velocity of 60 meters per second and it's going to have an acceleration of f meter per second squared, but it's a deceleration, which means that the acceleration is actually in the opposite direction to the velocity. So therefore, the acceleration is going to be in this direction. So we have an acceleration in this direction of f meters per second squared. So right now, this is what's going to happen at the time t equals 0. So I'm going to go down here and I'm going to indicate that this is occurring at time t equals 0. Now after time t equals 0, the particle is going to continue moving in this direction, but it's going to get slower and slower. It's going to continue moving in the positive direction and eventually it's going to stop. So let's suppose it stops at this point, which I'm going to call point, let's say A. So at point A, the particle stops. Now we don't know the exact time that it stops, but we can find the time based on the velocity and the acceleration. Now we know that v is equal to u plus at. At this point, the final velocity v is equal to 0. The initial velocity u was equal to 60 and at is going to be equal to negative f times the time which we don't know. Now the reason here that this f is negative is because considering the positive direction in this direction, we can see the acceleration is actually negative since it's in the inverse direction. Now considering this, we can see that this can be rearranged to get that t is equal to 60 over f, meaning that the particle is going to stop at the time t equals 60 over f. Now I'm not going to write the workings for this, I'm just going to write that the particle comes to rest at this point right here, which is t equals 60 divided by f. Now at this point, the particle comes to rest, it has velocity of 0, so v equals 0, and it has an acceleration in this direction of still f meters per second squared. Now as we can see, it has that same constant acceleration after that point as it moves towards O. So it's moving towards the point O with that same constant acceleration of f meters per second squared that it had at the start when it passed O initially. So now after this, it starts moving in this direction towards the point O. And this is what's going to happen. Now similarly, if we consider the other particle, which is the particle Q, the particle Q starts at the point O, but it starts moving at time t equals 30 of f. So here we can see this time is t equals 60 of f. At half of that time, t equals 30 of f. The other particle, which is the particle O, starts moving in this direction with an initial velocity of 0, since here we can see it starts from rest with only its acceleration of f meters per second squared. So if we mark it, the velocity here is 0 meters per second, but the acceleration in this direction is f meters per second squared. So it says that the particle starts like this, it goes, and as it goes, it eventually stops accelerating at some point which we don't know, but it stops accelerating when it reaches a velocity of 30 meters per second. Now considering that, we can see, if we consider again v equals u plus at, v equals u plus at, v here, the final velocity is going to be 30, u in this case is going to be equal to 0, so 0 plus at, and a in this case is positive, it's positive f times t, and we can see this means that t is equal to 30 of f, meaning that the time taken from the initial time until the particle stops accelerating and starts moving at the constant velocity is going to be 30 over f. So if the particle already starts moving at t equals 30 over f, which I'm going to indicate here, t equals 30 over f, then it's going to stop accelerating like this or somewhere over here at t equals 30 over f plus this 30 over f, which is going to be t equals 60 over f. So we can see at the same time that particle A stops moving, particle P stops moving. At the same time that particle P comes to rest, the other particle Q, is going to stop accelerating and move with a constant velocity at this point of 30 meters per second. Now as it keeps moving, at a certain point, the particles P and Q are going to reach the same exact point in space. And that point is this point right here, which I'm going to call point B. So at point B, the distance from the origin to the point B that the particle Q has travelled is equal to the total displacement of the particle P all around until this point, which is again equal to OB. So the total displacement of the particle P and the particle Q are the same at this exact moment of time, at which point the two particles are at the physical point B. So now given this information, we can now start drawing the graph. If we consider these two motions, this motion is the particle P's motion, this is the motion of particle P, which I'm going to label, let's say here, particle P's motion, and down here in green what we have is particle Q's motion, particle Q's motion. And if we start considering the diagram and draw the velocity time graph, it's going to be something like this. We're going to draw the vertical axis like this, which is the velocity axis. We're going to draw the horizontal axis, which is the time axis, like this. And we can see for the two particles, if we consider velocity and time, the first particle P, starts with velocity of 60 meters per second. So if we mark on this diagram 60, which is somewhere over here, let's say 60 meters per second, this part is going to have a downward curve because it's going to have a deceleration, and the gradient of the curve is going to be f meter per second squared. So it's going to look something like this. Now since the particle also starts traveling the reverse direction like this, we can see that this particle is going to have a negative component in its velocity at some point, meaning that this graph right here needs to pass the x-axis like this. It's going to continue downward in the negative direction like so. Now, since we know that the particle P comes to rest at t equals 60 over f, we can say that if this point here is time t equals 0, then this point here is going to be at time t equals 60 over f. Now furthermore, the particle continues accelerating in this direction, and we don't know when it stops accelerating, but we know that when it does, it's going to be at the point B. Now after that, if we consider the other particle Q, particle Q starts with velocity equals 0, meaning particle Q is going to be starting at the origin. But after that, as it accelerates, it's going to continue accelerating, and it's going to start accelerating at t equals 30 over f and finish accelerating at t equals 60 over f, and as it finishes, it's going to have velocity of 30 meters per second. So exactly half of this 60 meter per second value. So it's going to be somewhere over, let's say here, this is 30 meters per second, and at this point along the graph, it is going to have this velocity when the time is equal to t equals 60 over f. So if we just draw a horizontal line, a horizontal dotted line like this, at time t equals 60 over f, which is going to be this time right here, the particle is going to have its maximum velocity, and since we know it starts moving at t equals 30 over f, which is somewhere over here, t equals 30 over f, we know that the graph of this line is going to look like this, and after the point at which t equals 60 over f, we can see it moves its constant velocity of 30 meters per second, which means that the graph is going to be horizontal like this. It's going to be horizontal at the velocity of 30 meters per second. So it's going to look like that. So this is basically complete. Now all we need to do is to draw some extra lines that are going to indicate where the two particles touch the exact same point along this line. So for that, I'm going to draw a vertical line somewhere over here. And this vertical line is going to be the vertical line at which the particles are going to intersect. So basically, if we consider the displacements under each of these graphs, this displacement right here, the area under this curve, and the other displacement, which is going to be the total signed area under this curve, both of those areas are going to sum to the same value at this point right here. At the time here, which we don't have a value right now, but I'm going to call it, let's say, t equals capital T. So at this point, both of the particles are going to be at the same exact point. Now in order to use this diagram for something, we're going to label a bunch of points and also label a bunch of values. Now first off, we know that the particles P and Q meet 10 seconds after the particle Q reaches a constant velocity, which means that if we consider this point and this point, the horizontal distance here from this point to this point, which is this distance right here, is 10 seconds. Furthermore, if we consider labeling each of these points, this point right here is the origin. Let's call this point, let's say, where we can't use A or B, since we already used the points A and B in this diagram up here. So let's say that this point here is C, and then let's say this point here is, say, D. Let's call this point E. Let's call this point F or something. Let's call this point G, and let's call this point H, and let's call this point here I. So now we have a bunch of points that we can use to reference different areas in this graph, which we can then use to solve these equations. So now, considering this diagram, since we know that both particles meet, meaning that both of them have the same displacement, which is OB, the distance OB from the point O, we can say that the displacement of these two particles at the time t equals capital T, which is going to be t equals 60 over f plus 10 seconds, both particles are going to be at the same exact point. So considering that if we go to a new page, we can say that since particles P and Q meet at B at time t equals capital T, which is of course going to be 60 over f plus 10, but let's ignore that for now. Let's just say capital T. At this point, since they meet, area under the curve of P is equal to area under the curve of Q. Since if we consider the velocity time graph, the area under the velocity time graph is going to be equal to the displacement of the particle. So considering these two graphs, this graph here is the motion of P, and this graph is the motion of Q. Motion of Q. Now given this, if we consider what we have, this area minus this area, since this area is of course negative, is going to be the total displacement of P. And this area entirely is going to be the total displacement of Q. So therefore, if we write down the areas of P and areas of Q, the area of P is going to be equal to the area OCD minus the area DIE. So therefore, this is going to be equal to, for this side, area OCD minus the area DIE. That's going to be equal to the areas under the curve of Q, which is going to be this entire area here, which is the area DFG plus the area DGHI. So we can label those two as well. This is going to be the area DFG plus the area of DGHI. Now writing out these things, the area OCD is the area of this triangle. We can see the height of this triangle is 60 and the base of this triangle is going to be 60 over f minus 0. So therefore, the area of this triangle OCD is going to be half times the height, which is 60, times the base, which is 60 over f minus 0, minus the area DIE, which is the area of this triangle right here. If you consider this triangle, this height we don't know, but we know the gradient. The gradient here, the gradient which I'm going to label like this, the gradient equals, or we could say is negative f meters per second squared. So therefore, this height here is going to be whatever this length is, which we know to be 10 times f. So therefore, this is going to be 10f. Now we know the total area here is going to be half into base into height, or half into 10 into 10f. So therefore, minus half into 10 into 10f. Now this is going to be equal to the other area, which is this area. The area DFG is going to be the area of this triangle, which if you consider the base and the height is going to be 30 and the base is going to be t equals 60 over f minus t equals 30 over f. So therefore, it's going to be equal to half into base into height, half into 30 into 60 over f minus 30 over f, which is of course going to be equal to 30 over f, plus the area DGHI, which if you consider the height here is 30, the base is 10, so therefore we have height of 30 into base of 10, which is going to be 300, but we'll write it as 30 into 10. Now since this is all in SI units, we don't actually have to add any units here, since all of the units are going to be the exact same. So now if we take this and simplify, we can see on the left we have half times 60 over f, which is going to be equal to 30 times 60 over f, or 1800 over f, and this part is going to be 100f times half, which is going to be minus 50f, is equal to, and on the other side we have half into 30 over f, which is going to be 15 times 30 over f, which if you multiply is going to be 450 over f, plus, and this part here is just 300, so plus just 300. So we have this equation which you can solve to find f. Now to solve this equation, we need to take everything to one side. If we do so, we can see if we take these two to the other side, we're going to have 50f plus 300, and then this is going to be 450 over f minus 1800 over f, which is going to be negative 1350 over f equals 0. We can reduce this to a quadratic equation if we multiply everything by f, since f is of course not equal to 0, is greater than 0. Doing so, we get 50 f squared plus 300 f minus 1350 equals 0. Now if we divide everything by 50 here, we can see we get f squared plus 6f, and if you divide 1350 by 50, we're going to get 27 equals 0. Now finally, we can see if we factorize this thing, this is going to be equal to f minus 3 times f plus 9. You can see that because minus 3 times 9 is going to give us 27, actually minus 27, and minus 3 plus 9 is going to give us plus 6. So therefore, this factorizes to f minus 3 times f plus 9 equals 0, which gives us either f equals 3 or f equals minus 9. And out of these two, f equals 3 is the correct answer, since f is going to be greater than 0, as it was instructed above over here. In the question, it clearly said f greater than 0. So we can say, because f greater than 0, which is this symbol right here, because f greater than 0, f has to be equal to 3. So we've shown that f is equal to 3. Now finally, if we consider what they've last given us, they've said and that the distance from O to the point at which the particles meet is 450 meters. So considering that one, the distance from O to where the particles meet is the distance OB, since the point B is where the particles meet. And as we found up here, since both of these distances are equal and are both also equal to the total distance OD, which I could actually write down over here. I didn't really have to back then, but I could write it down now. OB, since they're both equal to this distance, we can say we can substitute either of these things in order to find OB. So if I substitute this one, we have 450 over F plus 300. So therefore I can say the distance OB is equal to 450 divided by F plus 300, and the unit of course is going to be equal to meters, which if you simplify down is going to be equal to 450 divided by 3 plus 300 meters, which is going to be 150 plus 300 meters, which finally is 450 meters. And hence we have shown that the total distance from the point O to the point at which the particles meet, which is the point B, is going to be equal to 450 meters, and hence that's the end of the question. Now finally, considering the marks awarded for this question, this part at the start that I drew to better explain to you the motion of the particles P and Q actually doesn't get any marks because they didn't ask us to draw it. Instead, where you start getting marks is the velocity time diagram. Now at this point, you need to have the velocity properly marked, you need to have the time properly marked, and you need to have all of these values properly marked. Given that, for the motion of P, from the point at which it has an initial velocity of 60 meters per second until it gets at rest, which is basically this part of the graph, you get 5 marks, and after that, from the point at which it starts moving in the reverse direction until the point that it meets the other particle Q, you get another 5 marks. So basically this part of the graph gets 5 marks, and this part of the graph gets 5 marks. Similarly, for the motion of the particle Q, from this point at rest until this point right here, for this part of the graph, you get 5 marks, and after that, at constant velocity for this part of the graph, you get another 5 marks. Now of course this is all provided that all of the values, the axis and everything is marked correctly. After this, when you consider the motion of the particles and you consider the distances that they travel, when you write out this equation that the distance OB is equal to the area OCD minus the area DIE, it's also equal to the area DFG plus the area DGHI, when you write these two areas being equal to each other, you get 10 marks. When you then individually substitute each of these areas from the graph that you have, for this area you get 5 marks, this area you get 5 marks, this area you get 5 marks, and this area you get 5 marks. Now after this, when you simplify down and you get this quadratic equation right here, before you simplify, when you get this part or this part, you get 5 marks. When you then factorize that quadratic expression, or maybe sometimes you might use the quadratic formula for it, that's also alright, but this is the easy factorizable one. When you get to this kind of thing where you have two solutions, you get 5 marks, and then when you figure out that the correct solution is f equals 3, since the solution is positive and cannot be negative 9, you get another 5 marks. Now after this, when you resubstitute the value of f equals 3 to find the distance OB, which is the distance from the point O to the point where the two particles meet each other, when you substitute and simplify to get 450 meters, you get a total of 10 marks for that. And that's going to be all for this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.